Alrighty, everyone, just getting myself set up. We're just about ready to go. All right, so I am checking the chat as well. So if you have any questions along the way, feel free to pop them into the chat so I can see where you're getting stuck. And hopefully we will be able to practice some of our maths questions. I've had a request to go over arithmetic sequences in particular, which is really neat because I made a video about that just yesterday. So that would be a really good opportunity to practice some of those questions. I've also got a time series question ready to go as well. So that's sort of the general plan. But if you have any requests, feel free to pop them into the chat. I will be checking that as we go along. Okay, so let's get started on a question then. Okay, so like I said, my first request was about arithmetic sequences. So let's do a question on that. Okay, so here it goes. In a new plan for telephone charges for international calls to Europe, a company suggests $5 for the first minute and then $1.20 for each minute. This is summarized in the following table, and you can see that there. First minute, $5, and then the next one, an extra $1.20, and so on. Okay, so the first thing we need to do is write the recursive rule for this sequence. Okay, so first of all, you would be asking yourself, well, is this an arithmetic and geometric sequence, and how do I know the difference between them? Okay, and my clue there is in the wording of the question here. Okay, so I can see that my sequence is going to be increasing by the same amount each minute. So that tells me that this is arithmetic sequence. So we call that a common difference. Okay, which is symbolized by the letter D. Okay, so it has a common difference, therefore it must be an arithmetic sequence. Now, do we know what this next term here means? Recursive rule. Have we seen that? Okay, so if you know what you're doing there, I'd like you to go ahead and try and answer part A. If you are looking at that question and going, I've never heard of a recursive rule in my life, I will give you a little hint. Okay, there's your hint if you don't know what a recursive rule is. Okay, that's the general format it takes. Okay, and if that notation is confusing to you, I would like you to think about what these symbols mean. Okay, so for example, what does this notation mean, T1? Okay, well that stands for the first term. So what would be the value of the first term in this sequence of numbers that we have here? Okay, so you can fill that in. And then for this other section, Tn stands for any term or the current term, and Tn plus 1 would be the next term to the current term. Okay, so what this rule is saying, to find the next term, you take the current term and add the common difference. and we've already talked about what the common difference is. So essentially all you need to do for this question is substitute in values into the place of the common difference and tell me what the first term is. That's what you need to fill in, okay? So if you haven't already done so, write your answer to that question, and then I will show you the correct solution. Okay, once again, feel free, if you're stuck, to ask any questions in the chat. I am keeping an eye out, so feel free to pop them in there. So the correct answer for this would be a common difference of $1.20, and the first term is 5. Okay, not too hard so far. Okay, this is where we get a little bit trickier. Here you need the general rule for the nth term. Okay, this is the one that is given to you on your formula sheet. So if you have a formula sheet handy, you can get that out and take a look. You will notice though that the recursive rule is not on the formula sheet, so you do need to know that one. Okay, so if you want to have a go at B, start by writing that general rule for the nth term for an arithmetic sequence. Should look a little something like this. Okay, so you can see we've still got very similar variables in there. They're just kind of in a different form, because the difference between the recursive rule and the general rule depends on, you know, what purpose, what you're trying to answer with this question. Okay, so your next step would be to substitute those same values from the previous question into the general rule. Give that a go. Okay, how'd we go with that? Substituted pretty easy. However, you'll notice that the question wants this in simplified form. Okay, and the key there is that we still have brackets. So we can get rid of these brackets by multiplying 1.2 by n, but also 1.2 times -1. So have a go at expanding those brackets. Okay, 1.2 times n would be 1.2n. 1.2 times -1 gives you -1.2, because a negative times positive is negative. Okay. Now we just need to collect any like terms. Can you see some like terms there? Hopefully. We can combine this and this. So that becomes 5, take away 1.2. So go ahead, have a go at writing this in its most simple form. You should get 1.2n plus 3.8 as your final answer there. Okay. How'd we go? Hopefully we all got that one out and you understand what it means when it says simplified form. Okay. If you have any questions or if you're stuck on anything, pop them in the chat. I am happy to answer. Okay, let's have a look at C now. We need our answer from part B to calculate the charge of a call, a 10-minute call. Okay, so have a think about our equation here. And what is being represented? What would the minutes be in this case? If I go back up to the table, you can see there's a clue here. Okay. So in this case, we need our rule. And we need to substitute in 10 into the place of n, okay? That's how we would find the cost of a 10-minute call. Have a go at doing that. Give you a minute's head start, and then I'll show you the answer. Okay, so to find the cost of a 10-minute call, which would be term 10, we get this, 1.2 times 10 plus 3.8, like so. And when you multiply all that out, you get an answer of $15.80. How did we go? Okay, let's have a look at part D now, where you have to use the rule again that we came up with and calculate how long a call you could have if you've only got $42.20. Okay, so think about where you would have to substitute into this equation, the $42.20. Where would you have to substitute that? Okay, the answer is here. And now we need to solve for n. Okay, so use your algebra skills to solve for n. I'll give you a little head start. Okay, so I would take away 3.8 from both sides, like so. That gives me 3840 equals 1.2 n. Whoops, n, not m. And then I would divide by 1.2. And we get an answer of 32 minutes. All right. How did we go with that one? So that's a question that involves arithmetic sequences. Okay, so I'm going to give you another one to have a go at that's very similar. Okay, this question I pinched from the 2020 external exam. Okay, so this is a question that turned up on the external exam at the end of last year. Okay, using an arithmetic sequence. So I'm going to leave that on the screen for a couple of minutes. And I want everyone at home to get out pen and paper, calculator, formula sheet, and have a go at this question. And then I will show you the solution. Okay. All right, if you're stuck at any point, feel free to write into the chat what you're getting stuck on and let me know. It's okay, no one will bite you if you put your difficulties in the comments. Just like your teachers always say, if one person has a question, then everybody probably has the same question. Okay, now the answer to this question, part A, determine the common difference, is 43. Okay. If you just wrote 43, though, you're only going to get 1 mark. But you can see this is a 2-mark question. So you get 1 mark for determining that the common difference is 43, but you also get a mark for showing sort of use of a model, okay, an arithmetic sequence. Okay, so you do actually have to demonstrate that as well. Okay, so I can see in the question that it's supposed to be an arithmetic sequence. Okay, and I can see some information here, 353 people on the first day. So I'm going to take the first day to mean T1, and I'm going to take 439 people to mean the third day, term 3. So that's the first bit of information I would write down. I would write T1 equals 353 and T3 equals 439. Okay. And then what I would do is I would substitute this into the general rule, the one that is on your formula sheet. Goes like this. Okay, so I can substitute T1 into there, and then I will also use T3. Term 3 is going to be, T1 is 353, we know that. And I'm going to substitute 3 into there. And I know term 3 is this. I know 3 minus 1 is 2, like so. And now I just need to solve for D. Okay, so if I take away 353 from both sides, I get 86. And then I divide by 2, I get a common difference of 43. Okay, so you'd get 1 mark for getting this answer of the common difference being 43. And then you'd get another mark for showing some kind of model. You could also do this through recursion, but I think the most efficient way to do it is with that general rule. Okay, so how do we go with that one? Okay, I now want you, I'll give you another minute or so to have a go at part B now that we know what the common difference is. See if you can figure out the number of people who will attend on the 6th day. Have a go at someone just asked, is the 6th day T6? Yes, it is. We are going to call that T6, which means our n value is going to be 6. And you can substitute that into the equation. Okay, so let's go through the answer now. So once again, I would use that general rule. You could also use recursion if you want to, but I think this is a little bit quicker. We're figuring out term 6 because it's the 6th day. Our first term was 353, and we're substituting 6 into the place of n. And our common difference is 43. Couple that into your calculator, and you get 568 people. Okay? How did we go? Did we all get that answer? Once again, if you only wrote that answer, you would only get 1 mark. Okay? And this is a 2-mark question. You have to show your mathematical model as well. So you would have to show substitution into the general rule to get that mark as well. Okay? All right. Let's try one that's a bit different now. Okay. Still sequences. We've got a swimming pool filled with 200,000 litres of water. And under certain conditions, 2% of the water in the pool will evaporate each day. Now, first of all, is this going to be an arithmetic or geometric sequence? Think to yourself. And arithmetic or geometric sequence, and how would you know if it's an arithmetic or geometric sequence? Okay, because we've got to look for clues. Feel free to pop your answer in the chat. You're all very quiet today. Okay, so the answer to that question is it is a geometric sequence. And I know this because of this clue here. Okay, because it's a percentage and not an absolute amount. Okay, so if I go back up to this one here, I knew it was an arithmetic sequence because they gave me an absolute amount that it was increasing by each term. Okay, so that was my clue. Whereas this one, you can see it's not an absolute amount, it's a percentage. So that's how I know it is a geometric sequence. Okay, so what I need to do here is I need to write this as the general rule for the nth term. This is once again that formula that's given to you in the formula sheet. So see if you can find that, the general rule for the nth term for a geometric sequence. Find that one on your formula sheet. It looks like this. Okay, that's what it looks like. However, in this case, I would actually prefer to, instead of using 200,000 as the first term, I would actually prefer to make that term 0, like this. Okay. Now, the reason I'm doing that is because I'm starting with an initial value of 200,000 litres, and then each day would be another term. So if I start at 0, then day 1 would be term 1, day 2 would be term 2, day 3 would be term 3. Whereas if I start with 200,000 at term 1, then day 1 would be term 2, day 2 would be term 3, day 3 would be term 4. Can you see how confusing that's going to get? So that's why in this particular instance, I'm going to start at T0 instead of T1. Okay, I didn't do it up here because in this case, the first day was T1. So that matched really nicely. I didn't have to change anything there. Okay, so you just got to consider the context of your question sometimes. Okay, so in this case, I'm going to start from T0 and make T0 200,000 litres. Now, the other piece of information that I need in this equation is my R value, the common ratio. Okay, so in this case, I can see that the water is evaporating. So the amount of water in the pool is going to be decreasing. Okay, so if the water is decreasing, then that means this is going to be geometric decay. Okay, geometric decay. Now, if it is decay, then I know that my R value must be less than 1. Okay, all right. Because if R was more than 1 and I was multiplying, my number would keep getting bigger. But if my number is less than 1, if my R value is less than 1 and I keep multiplying, the number's going to get smaller. Okay, so decay. It's going to be getting smaller and smaller and smaller. Okay, now in the video I made yesterday, I used the example that an R value of 1.2 would represent a 20% increase. And an R value of 0.8 would represent a 20% decrease. Okay. Notice how I didn't put in 0.2 as my R value just because I wanted a 20% decrease. Okay. 8% is 20% less 10. Taken away from 100. Okay. So 0.8 represents a 20% decrease. Now I'm telling you all this because our R value then needs to be, if we're trying to represent a loss, a decrease of 2%, then I need to make my R value this, like that, or 100 minus 2% if you prefer. Okay. So in this case, my R value is going to be 0.98. Okay. Now that I have those two values, I've got my R value now, and I've got my initial starting value. I can substitute that into the formula that I wrote. Okay. And that'll get us our rule. And there we have it. That's our rule. For part B, we can now use that rule to find the amount of water in the pool at the end of the 8th day. And remember, because I started from 0, the 8th day is going to be the 8th term. So essentially what I'm doing is I'm taking that rule and I'm substituting 8 into the place of n because that's the 8th day, because I started at 0 in this case. Okay, pop that into your calculator and see what you get. I've got rounded to 2 decimal places in this case. Okay, there's my answer. So the amount of water that will be in the pool at the end of the 8th day is going to be 170,152.6 litres. Okay, all right. Let's see if you can apply that to a different situation now. Very similar situation. You can see that 15% value there. That should give you a clue. You can see the word reduces there. That's a clue. Okay. Someone asked, how come it isn't to the power of n minus 1? Yeah, that's what I was talking about at the beginning here. If you start with t1, then it has to be to the power of n minus 1. Whereas if I start at t0, then I just go to the power of n, because I've already taken away 1 by starting at 0. Okay? So it depends on the kind of question that you're doing. The reason I started with t0 is because it made sense to start with a value of 200,000 litres as my starting value, and then the next term would be day 1. Term 1, day 1. Term 2 would be day 2. Whereas if I started with 200,000 as my first term, then the second term would be day 1. The third term would be day 2, and now I'm getting confused, okay? So that's why I started that one at t0. Whereas if I go back up here, the first day was term 1. So it made sense to start at term 1 instead of term 0. And you can see the n minus 1 is still in here because I started at term 1 and not term 0. So that's the difference. If you start at term 1, do n minus 1. If you start at term 0, just do n. Okay? So have a read through that question. I'm going to give you a couple of minutes to have a go. So get your formula sheet out, get your calculator out, see if you can do this question. And then I'll drop back in with the solutions in a couple of minutes. All right, if you're stuck, I'm going to give you a couple of clues. I'm going to say that, are we using term 1? We could do that. And think about what your R value is going to be. This is geometric decay. Okay, so think about what your R value needs to be. Okay, so your R value needs to be 0.85, okay? Not 15, not 0.15, 0.85, because it's reducing by 15. So 100% minus 15% would give you 85%. So that's your R value, okay? So check that you use the right R value, okay? And then you can carry on. All right. There's actually 2 ways you can answer this question. You can use the general rule and then use trial and error. So you could write it like this: Tn equals 600,000 times 0.85 to the power of n minus 1. But you can't solve that equation algebraically, okay? Because you know you need it to be, what was it, less than 100,000. So you could try and substitute 100,000 in here. But the problem is, to solve an unknown where the unknown is a power, the only way to do that is to use your natural log, which is not something we cover in the general maths course, okay? So you can't solve this algebraically. Okay, so you've got some options. Number 1, you could use trial and error, where you just put whatever value into the place of n and just hope for the best, and then just keep digging around to try and find the right one. Or you could use recursion. Okay, where you could use this rule, Tn plus 1, which means the next term is found by taking the current term and multiplying by 0.85 with a first term of 600,000. Okay. Now, what you would have to do is get your calculator out. Get your calculator out and follow along with me. So if you've got your calculator there, I'm using the green scientific calculator, you know, the TI, I think it's TI 33 or something like that. I'm using that one, but every calculator should work somewhat similar. So I'm going to type in my first term, 600,000. And I'm going to press enter or equals, whatever you have in your calculator. And that stores it in the calculator's memory. So type in 600,000, press enter. And then multiply by 0.85. And then if you keep pressing enter, your calculator will keep multiplying by 0.85. And then you can just count the terms. So I've got my second term here is 510,000. My third term is 433,500. My next term, 368,475, etc., etc. And if you keep pressing enter and count the number of times you press enter, you eventually get to less than 100,000. Okay? So the 12th term should be this. And the 12th term would be 2018. The 13th term is where it finally drops below 100,000. Which would be 2019. Okay? So to answer the question, which is predict the year that the company should conduct its review, you would conclude, therefore, the company should conduct a review in 2019 as this is when production $100,000 tons. Is that what the question says? Yeah, per year. Okay? So write yourself a lovely little concluding sentence there. Because this is a 4-mark question, so you have to give them 4 marks worth of working to mark. Okay? It's a problem-solving question, so I always try and answer with a sentence or a concluding sentence like that. Okay, is there any questions about that one? How did we go? Were we able to get the right R value? Some of us may have used the general rule and used trial and error to find when it went below 100,000. And some of us may have used recursion, okay? And doing it in your calculator is a really quick and easy way to do it, as long as you write your recurrence relation to show that you know what you're talking about. Okay, now I think we're going to move on. Yeah, I'm going to move on from arithmetic and geometric sequences. So if you have any last minute questions about that topic, now's the time to put them in the chat. So we're going to move on to a time series question after this. You're also welcome to put any requests in the chat. If you have anything you want me to explain or a particular question you would like to work on instead, now's the time to make a suggestion. Okay, well, let's have a go at this one then. So, all right. So the table below shows the number of caravans sold by a certain company in the years. Oops, can't even get the years right. Let me try that again. Go, 2017 to 2018. Develop a least squares line to model the sales after deseasonalizing the data and use this to predict the sales for Q3 2019 and evaluate the reasonableness of your prediction. Okay, so this is a really big question. It's got a lot of components in it. Okay, so if you're looking at that and you're stuck, the difficulty is that the question is telling you to develop the least squares line to model the sales. But the problem is there's a few steps that you need to do before you get to that step that they're not telling you about. And that's what makes this a complex question, okay? Complex questions, particularly complex unfamiliar questions, won't be telling you easy answers. It won't be telling you what to do, or it won't be telling you all of the steps that you need to do to get to the solution, okay? So that's kind of the difficulty of it, okay? So if you don't know the first step that you're going to need to do is to calculate the seasonal indices. Okay? To calculate the seasonal indices, this is topic 2, by the way. The first thing you need to do is come up with an average for the year. So I just like to do that by adding an extra column here. So the first thing I want everyone to do is figure out the average sales for 2017 and then the average sales for 2018. So you have to add up those 4 values and divide by 4. Do that first. I'm going to round to 2 decimal places. That's what I get for the first one. Have a go at 2018 if you haven't already done so. The average. I get 36 for that one. Okay. Right. Now that we've got our average for each year, we can now calculate the seasonal indices. Okay. So what I'm going to do is I'm going to sort of redraw this table. Oops. I move that down a bit. There we go. So redraw the table like so. And you're going to need an average row as well, because you're going to need an average for each quarter. Okay. All right. Now, to get the seasonal index for our first quarter of 2017 here, you need to divide by the average. Like so. Okay, because if you think about it, quarter 1, 23, is a little bit below average. Okay, so we're expecting to see a seasonal index that is below 1, because 1 would be exactly average. Okay, so I get 0.84. I'm rounding to 2 decimal places there. Okay, let's do the next one together. We've got 13. Once again, we're expecting this to be below average. So 13 divided by 27.25. What do you get? I got 0.48. Okay, I'm going to give you another 2 minutes And I would like you to complete that row and then also do 2018. Remember, you have to use a different average for 2018. Okay, I'm going to give you 2 minutes. Finish filling out that table. Okay, I'm just going to start filling in the answers here so you can check your working. Okay, so that should be your seasonal indices for each of those quarters. Okay. Now, we need an average seasonal index for quarter one. Okay, so we've got 0.84 and 0.89. So what you need to do is add those two together and divide by 2. Get an average for that, and it's 0.87. Okay. Do the next 3, please. Find the average seasonal index for each of those quarters. Once again, if you have any questions, if you're stuck on anything, make sure to post them in the chat. I am keeping an eye on it. Okay, so I got 0.49 for quarter 2. I got 1.30 for quarter 3 and 1.35 for quarter 4. Okay, because that's going to be important for our next step. The next step we need to do is to de-seasonalize the data. Which is a funny word, but it means exactly what it says. This data that we have up here, you can see is seasonalized. There's seasons in it. Quarter 2, which you could imagine as autumn if you want to call this summer, autumn, winter, spring, or something like that. But not necessarily, but in this case, it just helps to visualize it. You can see that quarter 2 is always the lowest amount of caravans sold, whereas the highest is always sort of quarter 3 and quarter 4, okay, with quarter 4 being even better than quarter 3. So you can always say there's a consistent pattern in there, okay? So our data is seasonal. There are patterns according to the seasons. So to de-seasonalize the data, we're going to try and remove the seasonal variation. Okay, so to remove the seasonal variation, we're going to do that by dividing by the average seasonal index, which is what we calculated in step 1. Okay, so let's do that. I'm going to redraw my table again. Okay, I'm just going to even that up. Lovely. So what I'm going to do is I'm going to take the first value, which is 23, and I'm going to divide it by the Q1 seasonal index, which in this case is 0.87. Okay. The next one would be 13 divided by the Q2 seasonal index, which would be 0.49. Okay. Q3, 36, 37. Just copying this down, 32, 18. And 46, 48. Okay, and I'm going to divide by their seasonal indices for that quarter, the average one. Like so. Okay. And what you'll notice is the numbers that are below average, like quarter one and quarter two, will increase in value, whereas the ones that are above average, like quarter three and quarter four, are going to decrease in value. Because remember what I said, what we're doing is we're de-seasonalizing the data. We're taking that seasonal variation out of the data. So the first one there would be 26.44. The next one, 26.53. Okay, I'm going to give you another 2 minutes. If you haven't finished, complete that table, please. Okay, so there is my de-seasonalized data. Okay. All right, so we're getting closer to our actual goal here, which is to fit a least squares line to this data. Okay. So in order to do that, we need the slope and y-intercept. So if you think about it, least squares line looks like this. Y equals, A plus BX. Okay, and if you're thinking to yourself, I have never heard of a least squares line before, I don't know what this formula is. Well, no worries. I have a video that I recorded about a week ago that goes through bivariate data analysis, topic 1, okay, which is where this content is found. Okay, so you can find that video where I go over least squares line. All of my videos have timestamps so that you can skip around to the part that you want, because they are admittedly quite long. But I think it's good value, considering topic 1 is 25 hours to teach according to the syllabus. I think I'm doing pretty well covering it in about an hour and a bit. All right, so step 3 is to use your calculator. So that you can get the y-intercept and the slope, okay? So if you've got the green Texas Instruments calculator like me, you want to press the data button, okay? And make sure there's no info in there. You might need to reset it if there's info in there, okay? And you're going to see you're going to end up with some columns. One says L1, one says L2. In the L1 column, you want the quarter number. So quarter 1, quarter 2, quarter 3, quarter 4, which would be 2017. Quarter 5, 6, 7, 8 would be 2018. Like so. And in the L2 column, you're going to put your deseasonalized data. The reason we put the deseasonalized data in and not the raw data is because it's more accurate if we remove the seasonal variation. Okay, so you're going to want to put that data in there, which is okay, so you're entering that into your calculator in the data button. Okay, enter all that in. Okay, once you've done that, okay, you should be able to press the second function and then stat button. And you want to choose 2var data. So the second function button looks like that. And then the data button, which has stat written above it. Like that. Okay. And then you want to choose 2var data. That stands for 2 variables, because we are doing bivariate data analysis. We did do univariate data analysis in year 11. It was unit 2, topic 3. Okay, but now we are doing 2var bivariate data analysis. So you want to choose that one there. Now, once you choose that, you just need to make sure your settings say that the X data is column L1 and that the Y data is column L2. Okay, because that's how we set this up. This is our X variable, this is our Y variable, or the explanatory variable, and the response variable. Okay, then it brings up a whole list of numbers. So it does things like this. 1, n equals 8. Okay, that means that there are 8 data values there. Okay, does 2, x bar equals 4.5. That's just telling you the mean of x. Okay, you can keep scrolling through, but what we want is scrolling down to capital D, E, and F. In mine, D says A equals 1.72, and I'm just going to round it there. Okay. It says B equals 23.82. I'm rounding that to 2 decimal places. And then it says that R equals 0.86. I'm rounding to 2 decimal places. Okay. So in this case, these two, A and B, relate to our y-intercept and our slope. But unfortunately, they are the wrong way around. Okay. So in this case, this is the slope and this is the y-intercept. Okay. And then this, of course, is our correlation coefficient. So 2 L's or 1? I can never remember. Okay, so that takes us to our next step, step 4. Write your least squares line. Which in this case would be the deseasonalized sales equal 23.82, because that's our y-intercept, plus 1.72 times the quarter. That's our least squares line. Now we can finally make a prediction. And if we go back up to the question, it says predict the sales for Q3 of 2019. And if you think about it, Q4 of 2018 was 8 in our list here. So Q3 of 2019 would be 9, 10, 11. So that means we need to substitute in 11 into the quarter. It's quarter number 11. So we're going to do like that. Put that into your calculator and get your answer. I get 42.74. Hopefully we've done that right. Okay. Last step. We can re-seasonalize our sales. Our prediction, I mean. Okay, because remember we took out the seasonal variation when we made the prediction. So now if we want to make our prediction accurate, we may need to re-seasonalize our prediction. So to do that, we need to take our prediction and multiply it by its seasonal index for that quarter. If you remember, this is Q3 of 2019. So the seasonal index we need is, of course, this one here. Okay, because that's Q3's seasonal index. So we're going to multiply our prediction by 1.3, and we get 55.56, which I'm going to round to 56 because this is the number of caravans sold. Okay. And then the last bit of the question is to evaluate the reasonableness of your prediction. And there's a few ways you can do that. You could talk about the fact that this is accurate because we had a decent amount of data to base this on. We de-seasonalized our data first, and that made it more accurate. And then we re-seasonalized our prediction. You could also talk about the fact that we had a strong correlation to our data, which is very nice. Okay, so there's a few different ways you could evaluate the reasonableness of your solutions there. Okay. All right, so we've been going for about an hour and 15 minutes now. So unless anyone has any last minute questions, I might call it there because that's probably a job well done. Any questions? Pop them in the comments. All right, well, if that's the case, I will call it quits there. Good session, everyone. Thank you for coming. If you have any requests for next time, oh, no worries, Millie and Ella, happy to help. I will do this again in the future if you found it useful. Let me know if there's any particular times that work for you. If you like this sort of Sunday afternoon slot, or maybe a weeknight might work better, let me know. And of course, send me any requests. If there's a question you're stuck on, you can send that to me and I'd be happy to go through it. If there's a particular topic you want to work on, let me know. Okay, happy to help out. Okay. All right. Well, I will see you all next time. Have a lovely rest of your weekend and happy studying.